Hi, everyone. It is me again, like always. So today we're going over October 20th and 21st, lesson 1.6 on polynomial division. And I actually am still in school. You all are just leaving right now. I see you in the hallways. So if you hear people come in and they're sweeping the floor or like doing all the things that are magically done to keep the school running, you might hear like a trash can roll in or something like that. So just ignore those. So welcome. I'm glad to be here with you. And a reminder that I do have certain slides that I want to go over today. Probably the most requested was slide 20. So we're definitely going to go over slide 20. I am going to skip through the slides a little bit more than normal, just because each problem takes a little bit longer to do and to really fully explain. So let's get started. All right. So these first three were just kind of check-ins and if you want office hours. So let's look at 4. Okay. This is just a review of multiplying binomial times a binomial. All right. And just kind of a reminder, let's do this maybe. Okay. Just a reminder that this is called factored form. Let's see. I don't know if there's a way I can type on this, but anyways, factored. All right. Okay. So once I actually multiply x plus 3 times x plus 5, I will get it in standard form. All right. So we're just kind of going back and forth. And this lesson actually is, all right, so what if they give it to you in standard form? How do you then, instead of multiplying it, right, how do you then divide it so that you can get back to factored form? All right, so let's just do a quick review of this. I'm guessing that this might be one that a lot of you are skipping. But the box method really just means that I want this is probably way too small. Well, let's just do this. The box method is just a way that we can multiply this. All right. The factors themselves, right? X plus 3 and x minus 5 need to always be outside of the box. The product or the standard form will be inside the box. So I've got x, and multiplication 2 times 3 is the same as 3 times 2. So it does not matter if you put x minus 5 on top or if you did as I did and put it on the side. Okay. All right, so here, x times x would give, oops, let me actually do this in a different color. Let's do blue. Okay, so this would give me x squared. X times 3 gives me 3x. All right, negative 5 times x gives me negative 5x. And negative 5 times a positive 3. Remember, negative times a positive always gives you a negative answer. So that would be negative 15. All right, a really important key point here that we're going to use once we get into factoring trinomials or even higher degrees than that is that if you look at these diagonals, this negative 5x, it is a like term. And by like term, I mean they've got the same variable x with the same exponent, right? So here I've got an x, but the fact that this is x squared, it stops it from being a like term. All right, so negative 5x, okay, plus 3x will give me negative 2x. Let's see if that pops up. Yay, okay. So once I've actually done the addition, done the subtraction, whatever I need to do to combine those like terms, then my answer, right, will be y equals oops, not plus, minus 2x, right? That's what I got when I combined. And then minus 15, right? Because I see the 15 right here. So if I go back to the pen, oops. Oh, wait, how do I go back? Oh, no. Oh man. Okay. So we got most of what the only thing I was going to do is I was going to rewrite this here so that it was next to where standard form was, right? So just another reminder. Oh man. Okay, I've got to figure that out. Just another reminder that the top one is factored form, the bottom one is standard form. All right. So now we're going to go to slide 9. And just a reminder, in a lot of these, there's a video with tips. Sometimes there's a video where the other teacher actually does the problem. Okay. All right. So here we go. Okay. So again, I see x squared plus an x term minus a number. This is telling me, hey, this is in standard form. I want to get it into factored form. So now I'm going the other direction. And so let's see, let's use this one. Okay, cool. So I am going to start with making a box, right? And with quadratics, I think you guys know it's like the typical 4 spaces, okay? It will change a little bit as our degrees get higher. Okay, so I start here with the 3x squared. Okay, and then I know that this last term, this negative 30, will go in the box on the bottom right-hand corner. Okay, so I've got 3x squared, I've got negative 30, and I know that the factors that I put to the left and on top have to multiply to give me that term. Okay, and all I know about this box and this box is that they will both be an x term, right? And they will combine. They'll either add or subtract to give me a positive 9, all right? Positive 9x. So let me just stop. Let me start at the top corner where I have 3x squared. I'm sorry. Okay. So I know that this would have to be something like 3x times x. Again, if you put the 3x on top, great, whatever. But 3x times x are pretty much the only two things you can multiply to give you 3x squared. All right, so now let's see. I know that I need 2 terms that will multiply to give me a negative 30. So I know I need a minus and a positive, okay? So I'm just gonna pick negative 10 and 3, okay? Because 3 times negative 10 gives me negative 30. All right, cool. So now let me just figure out, oops, wait, I can change the color up here. Cool. All right, so now I wanna see, all right, does that work? All right, so 3x times negative 10 would give me negative 30x, okay? And here, 3 times x would give me a positive 3x, okay? So negative 30 plus 3, that would give me negative 27, right? If I were to add or subtract these two. So that doesn't give me a positive 9x, right? And the fact that it doesn't even give me a 9, if it gave me a negative 9, I'd know, oh, okay, I'm on the right track, right? But the fact that it doesn't give me any kind of 9, it gives me a negative 27, I know that I really need to be choosing different factors, all right? So let me just see if I can erase. I don't know why I made those dots. Okay. All right, that's not so bad. Okay, so let me try, oh wait, I need to, right, these factors aren't working for me. They don't give me any kind of 9. All right, so I'm thinking 5 times 6 also gives me 30. All right, so let me try that. So I'm going to try -6 and a +5. Cool. 5 times -6 gives me -30. So here, 3 times -6 gives me a -18. And 5 times x gives me a +5x. All right. So let's see. -18 plus 5 would give me a -13. Right? That's still not the 9. And actually, I just remembered something. The fact that there's a number in front of this x might throw it off. Let me just try switching these, right? Put the 5 up here and the 6 down here. All right, so let me just try that because I actually forgot that we had a number in front of that x. All right, let me see if this works. Okay, so let's see, -5 and a +6. Okay, so 3 times -5 is -15. And 6 times x is 6x. All right, so 6x minus 15x. Oh, this gives me a -9x. I'm getting super close, right? So now I'm just going to change the signs. I'm going to make that positive and this negative. Okay, so 3x times 5 would give me a positive 15x, and -6 times x would give me a -6x. I think I got it. So 15x minus 6x does give me a positive 9x. Okay, so that's really cool. And sorry about that with the coefficient. If there's a coefficient in front of either of these beginning x terms, then then you do have to play around a little bit more. So you play around. We eventually got there. So my factors for this would be. Let me type this in. Y equals, and then on one side I've got 3x minus 6, and then I've got x plus 5. Okay. Now, some of you, and actually when I was with section 5, someone in that class said, wait a minute, there is a common factor in this parentheses, and that common factor is 3. 3 goes into 3, and 3 also goes into 6. So you can actually factor that greatest common factor out using multiplication to help you kind of like factor it out, right? So 3 times x gives me 3x, and 3 times a minus 2 gives me this -6, all right? So again, because there's a GCF here, I can actually pull that common factor out. Now, I don't want to forget about this factor. I also need to take that out. And this would be considered fully factored, right? Or factored completely. So actually, why don't I change this? So I'm going to just show that I'm factoring it completely here. Okay, and there we go. There are our factors. 3 is a factor, x minus 2 is a factor, and x plus 5 is a factor. Okay, so let's go to slide 12 now. And again, if there's one, well, for this one, if you're like, I don't know how to do it, watch this video. It goes over this this one in particular. But it's the same steps that we just did. Make your box, right? In the top left, you have 3x squared. In the bottom right, you have a positive 2. And just think, what times what gives me 3x squared? What times what gives me a positive 2, right? And the nice thing about 2 is there's only 2 factors, 1 and 2, right? So you might have to play around, but it shouldn't take too long. Okay. All right, 12. So here we go. I'm looking 2x squared minus 3x minus 14. So what are those factors? All right, so I'm going to draw my box. Okay, and remember again, this is standard form. Standard form goes inside of the box. The factors are what goes outside. All right, also known as like the product, right? The product would go inside the box. So 2x squared and a negative 14 goes here. So this is the easiest one to tackle, right? Only 2x times x would give you 2x squared. Okay. Now with negative 14, I've got a couple options. I can do 7 and 2, right? I can do 7 times 2. One of them would have to be negative. And I could also do 1 times 14. All right, so some combination of these factors. So let me try, I don't know, 7 and negative 2. Okay, so I know one of them has to be a negative, and negative 2 times 7 is negative 14. Okay, that works. So now 2x times 7 is 14x. Okay, negative 2 times x is negative 2x. So 14x minus 2x gives me 12x, not the negative 3 I need. Okay, so I'm actually just going to switch their place, right? So let's play around a little bit. Okay, I'm not going to change the negative just because whatever, I will if I have to. So I'm going to put the 7 here, the 2 here. I don't know why I always forget to erase this part too. Okay. All right, so let's change that. Okay, so now negative 7 times x is negative 7x, and 2x times 2 is 4x. Okay, 2 times 2 is 4. Yeah, okay. So negative 7 plus 4, right? I'm just adding the coefficients in my head, is a negative 3. Oh, and I need a negative 3. Great. So yeah, so that works, right? Let me do it over here. So negative 7x and a positive 4x, those like terms will combine to give me a negative 3x, right? And the reason I know that that's where my answer should be, right, is because it matches the middle term here. Okay, so I'm just gonna type that out. Y equals x plus 2, and then times 2x minus 7. All right, now in the last one we did, there was a greatest common factor. I'm just going to check both of my factors, both of my parentheses, to see if there's a greatest common factor anywhere. All right, so I see x plus 2. Nope, there's no factor that's common to x and 2 other than 1, right? 1 doesn't count because it doesn't change anything. And 2x minus 7. Nope, there's no factors of 2x that are the same as 7. Okay, great. So again, this up here is in standard form. And standard form is great for letting me know the shape of it. So I know that this would have an end function where you start up and end up. It would look like a U. And I know that my y-intercept is at negative 14. Great. Here, I can tell my x-intercepts, and that this parabola would cross the x-axis in 2 different places. Okay. So what do we have next? All right. So this is a great problem. And if you notice, now is when we're starting to factor cubic functions. All right. So this is explained through like this picture. And I also think that this teacher, put a video, okay, with here. So we're going to actually start on 16 because it's a very similar problem, right? So they tell you, hey, this is a cubic function, and they give you a factor. So it's the same thing, like in the slides that we just went through, same exact thing. Cubic function, and they give you one of the factors. All right. So here we are going to start a box, but I'm not quite sure how many spaces go in that box, right? But what I do know is that I have one factor, right? Right, factor, right? So that means that this factor would go outside of the box, all right? And then I can change color, yes, okay. And then this product would go inside. Oops, wait. All right, it does go inside, but I was actually trying to write standard form. Sometimes I get so caught up in like what color and all that stuff. So yeah, so this is standard. So you should be able to tell me what the y-intercept is here. And the end function, right? It's cubic. I know I'll start down here, end up here, okay? Okay, so let's actually get like, all right, how do we factor this? So we factor it by saying, all right, I'm gonna set up my box, right? It's gonna go a little longer just because it's x cubed. But here I still have one factor, right? So I'm gonna say x minus 7, all right? That is my factor. I know that it will go outside. All right, so remember this part, right, x to the third will go inside. And it's the same as the ones that we were doing before where the first term goes in the upper left corner. Eventually, we'll put the last term in the bottom right, but we're actually going to work this a little bit different, okay? Okay, so we can do this in a different color, it's fine. All right, so x times what would give me x to the third? Hopefully you're saying x squared. Okay, so I'm just asking myself, hey, what term do I have to multiply what I already know, right? I already know this x is here. What do I have to multiply that by to get x to the third? Okay, great. So now that I know this, for some reason, how I wrote the square is bothering me. Okay. So x squared. All right, so now that I know that this is part of the other factor, I can say, all right, x squared times negative 7. I know that this is negative 7x squared. Okay, so I look over here, and this is negative 7x squared. So what do I need to add or subtract to that to make these match, right? And the answer is they already do. I don't need to add or subtract anything to negative 7x squared to get negative 7x squared, the exact same thing, okay? So what I'm going to do is I'm gonna actually put 0x squared. I wanna make it so that the like terms, remember, like the diagonals are always gonna be like terms to combine, but I'm basically saying negative 7x squared plus nothing gives me itself, okay? So now x times what? Do you know? Right? I could just say 0, or if it helps you, if it makes you feel better, you could put 0x, but 0 times x is 0. There's not going to be a term there, right? Or we don't have to write it. Okay, so now let's just keep going. So I'll just say plus. Great. All right. So now 0x times negative 7. 0 times anything, right? It's still just going to give you 0. So I have 0. And again, just to keep like the like terms, 0x, sure. Okay. So now what do I have to add to 0x to get negative 16x? Hopefully you said negative 16x. I need all of the 16x's, the negative 16x's. Okay, so 0 minus 16 is negative 16, and that's exactly what we need for this coefficient of x. Okay, so now, all right, x times what would give me negative 16x? Negative 16, of course, right? So x times negative 16 gives me negative 16x. All right, so now negative, oh, I might need a calculator for this. I know it's going to give me a positive. Okay, so I know that much. So I'm just going to do negative 16 times negative 7 on my phone. Times 7. Oh, and it gives me a positive 112. And if I look over right here, there is that positive 112. All right. So the way that I would write this factor so far is a of x. Let me stay in my correct notation. All right. I'm having issues today. Don't mind me. Okay, so one of the factors is x minus 7, and the other factor is x to the second plus 0x minus 16. Okay, so now is a good time to remind ourselves that 0 times x is still 0, right? 0 times anything, 100, 1 billion, whatever. And x squared plus 0, anything plus 0, 20 plus 0 is still 20. X squared plus 0 is still x squared. So I actually don't even need that term in there. So I have factored it. I've used the fact that they've given me a factor of x minus 7. But they want this to be a product of 3 factors. All right? So I actually need to keep x minus 7. But this, if you look, it's got a square, right? So this is a kind of like, if I just were to look inside this factor, I would see that there's like a quadratic inside of that factor. And then when I multiply it by x minus 7, it turns into a cubic, right? But if I'm just looking at what's inside the parentheses, I have x squared minus 7. The thing is, just like the greatest common factor where we took out that 3 earlier, you can factor x squared minus 16 more. Okay, so I am going to erase what is here. If you need to take a screenshot, take a screenshot. If you're doing notes, great. But I am going to erase this right now. All right, here we go. Okay, well, this takes forever to erase. I feel like I should have Jeopardy music playing now. Okay. All right, we made it. Thank you for staying. Okay, so again, this part of it is the product, right? Like if I were just looking inside, like kind of peeking in, right, I would see a quadratic function, right? So that would be like my standard form if I'm just looking inside of that, inside of this parentheses, okay? So for that reason, when I make this box, I'm basically saying my new product, right? What I'm really trying to factor is x squared, oops, okay, minus 16. All right, whoa, why is this not, okay. Okay, so this is what I'm trying to factor. Right, so eventually it will be, 2 parentheses. So this is like my new like standard form, right? Even though you guys know it's cubic, but we're pretending for a minute. So that means it would go inside of this box. All right, so my first term would be in the top left. My last term, right, the number that has no variable, would go here, negative 16. Cool. I know that these terms would both end in x, and I also don't see any x's, right? That means that they'll have to, when I combine them, they'll have to like cancel out. They'll have to make a 0, right? Kind of like how we lost the 0 in here. We're going to have to kind of lose the 0 in here. And the way you do that is like x minus x 5x minus 5x, 20x minus 20x, whatever it is, it should be the same number with different signs. Okay, so now let me try this out. So let me change this to blue. Okay, so I know that x times x, that is the only combination of factors that when I multiply will give me x squared. All right, so now what gives me negative? Okay, so if I'm multiplying to get a negative 16, I know one of them has to be a negative. All right, so it could be 1 and 16. It could be 2 and 8. Or it could be 4 times 4. Okay, and of course, one of them would have to be negative, right? So would any of these add or subtract to 0? Remember, I don't see any x terms. I want it to have 0 x's, okay? So hopefully you're keying in on this, right? So if I make one of the factors x minus 4 and the other factor plus 4, this type of x squared minus 16, it's also called a difference of two squares. So you might be remembering that now. All right, so negative 4 times x is negative 4x. And x times a positive 4 is a positive 4x. So 4x minus 4x cancels out, which is again why we don't see any x term in the middle. All right, so if I look back at this, I keep the x minus 7 factor, but I can actually rewrite x squared minus 16 as x plus 4 and x minus 4. All right, this is what is considered complete factored form. So the first one was factored, right? If I said factor and you did it, great, that works. If I say factor it completely, then you have got to go through this extra step of taking the factor x squared minus 16 and factoring that one step further, right? So you just have more separate factors. All right, now I'm just going to take a quick glance. I don't see any common factors in any of these parentheses. So there's no GCF. Great. All right, so that would be considered factored fully. Okay, and the last one, no, we've got two more. So we're going, oh, actually, there was a question about 17. Sorry. Okay, so the fact that it has a fraction really doesn't mean anything, right? So we do the exact same steps. So if I know that this right here is my factor, that should key you into this goes outside. Okay, so let me just write down what I know. All right, so I know x and a negative 3/2. Okay. All right, so again, this is standard form. It would go inside of the box. So let me start with 2x to the third. So I know 2x to the third would go in the top left-hand corner of this box. Let me just kind of set it up. Okay, so cool. So now I get to like kind of figure out, well, what don't I know? All right, so x times 2x squared, right? So x times x squared gives me x to the third, and there's like an invisible 1 here, right? I think most of you remember that. 1 times 2 gives me the 2. All right, so now 2x squared times negative 3/2. Ooh, okay. So I'm just going to do like a little scrap paper work here. 2x squared times negative 3/2. Oh, is this too close to the bottom? Okay. All right, cool. So if we're multiplying a fraction, first of all, sometimes I like to put the other fraction just over 1. Right? So when you multiply fractions, you multiply straight across. You multiply numerator times numerator, denominator times denominator times denominator. Okay, I can talk. All right, so the first thing I notice is I've got negative times a negative. My answer is going to be positive. Okay. Now, 2 times 3 is 6. And then I've got the x squared. And 1 times 2 is 2. All right, now 6 divided by 2 is 3. That would give me 3x squared. All right, so it's a little bit more work, but same process. If you know that, like here I've got a 2 in the numerator and I'm multiplying it by a fraction that has a 2 in the denominator, you can cancel those 2's out here. 2 divided by 2 is 1, right? So that's why you can cancel out. And then x squared times negative x squared times negative 3 would give me this positive 3x squared. Okay, so that's what I'm going to put in here. I'm going to put in, wait, why did I make this 2x squared a negative? Did I mess that up? I think that was just my mistake. Okay, so that's fine. Let me fix it here. Okay, let me just check. This is a positive 2x squared times 1x. Okay, so yeah, I don't know why I made that a negative. Does that ever happen to you? Okay, the only thing that changes is now we have a positive times a negative, so this actually should be a negative 3x squared. And that's exactly what I'm going to put here. Negative 3x squared. Okay. All right, what am I trying to combine it with? What am I trying to get? Right? So I look over here, my x squared term is a negative x squared. And hopefully, again, you remember that there's an invisible 1 here. So it's kind of like, all right, negative 3 plus what will give me a negative 1? All right. So I'm thinking, I think it's a positive 2x squared. Right? So negative 3x squared plus 2x squared does give me a negative x squared. Cool. All right, so now we do the same process again. All right, 2x squared is right here. So, okay, 1x times what would give me 2x squared? All right, hopefully you said 2x. Okay, x times 2x gives me 2x squared. Great. Now, 2 times negative 3 halves, all right, let me do this again. So basically it's 2x. Let me go through this again. Okay. Sorry about that. All right, so here now we have 2x, and I'm just going to put it over 1 because I just wanted to make it look like a fraction. It's easier for me. All right, so we've got 2x times negative 3 halves. I'm going to do that trick I was talking about before, where if there's a 2 in the numerator, that cancels out with a 2 in the denominator as long as you're multiplying the fractions. All right, so that would leave me with x times negative 3. That would be negative 3x. All right, so I'm going to put negative 3x. All right. Now, I want to get negative 27x's. So if I already have 3 negatives, how many more negatives would I need to give me such a big number, right? A negative 27x. All right, so think about it. So I think I would need another negative 24x's, right? So negative 3x minus 24x should give me negative 27x. All right, so now let's do this again. What number times x would give me negative 24x? That is negative 24. All right, so x times negative 24 gives me negative 24x. Great. All right, so now I'm going to go back and do the math here again. All right. Okay, so negative 24, and again, because, whoa, Okay, again, because I'm multiplying it by a fraction, I want to make negative 24 into a fraction. And I can make any number into a fraction by putting it over 1. Okay, so, I thought I made a mistake again. This is a negative 24. Negative 24 times negative 3 halves. Okay, I don't know why this is being such a butthead. Okay. All right, so negative 24 times negative 3 halves, and I've double checked, I do mean a negative 24, so I'm going to have a positive answer here. Negative 24, let me use my calculator. The heck is negative 24 times 3? Okay, so I'm getting a positive 72 divided by 2. Okay, now if you said, hey, 2 goes into 2 once and 2 goes into 24 12 times, right? Making negative 24 into a negative 12. Great, you'll get the same answer. So negative 12 times negative 3 is the same thing as when I divide this. So 72 divided by 12, I think that's 36, but it is a long day that I'm having. Yes, and we get 36. Okay, so this last one would be 36. And I look up here, and exactly, that is my last term. Remember, the first term goes in the top left, and the last term, this plus 36, goes in the bottom right-hand corner. Okay, so I did an excellent job. I'm giving myself a pat on the back, and I'm going to type in here what I have so far. So I have x minus 3 halves. That's what they told me. And then I have 2x to the second power plus 2x minus 24. Okay. All right, so now if I want it to be completely factored, I am going to have to erase this, right? And I wish I could just magically like click something, but I'm going to erase this. And now which of the factors am I going to factor further? So look at them and see if you can come up with the answer to that. Right? Just like the last one where we like zoomed in and we were like, wait a minute, this is still a quadratic. Like, how can we factor this so that it's not a quadratic anymore? And in some slides, they even said we want 3 linear factors. And that's just because if I were to graph just this factor, I would see a line, right? Whereas if I were to graph this factor, I would see a quadratic. Right? So if x is the highest degree that you have inside your factor, they call that a linear factor. Okay, so hopefully you got to the fact that this needs to be factored a little bit further. All right, so let's do that. So we are trying to factor 2, oops. Okay, I'm just gonna write this one out. All right, we're trying to factor 2x squared plus 2x minus 24. Some of you might be noticing like, hey, there's a GCF here. There's a greatest common factor. You could factor it at this stage. That's fine. I'm going to factor it towards the end. Okay, so again, if I'm zooming in, I'm saying, all right, this quadratic is my product. It is what goes inside of the box, right? So I know my first term. Okay, let's try that again. My first term goes in the top left hand of the box. So that would be 2x squared. And my negative 24 would go in the bottom right hand corner. And I don't know what these are, but I know that they're both x's, and I know that they will be combining to give me a positive 2. All right, so let me play around with this. I know that some factors of negative 24, I know I'm going to need a positive and a negative. Okay, I'll keep that positive. Oh, and I know that 2x squared, I need a 2x. And I need a x, right? 2x times x gives me 2x squared. Great. So now I'm just going to play around. Let me choose a different color. Okay. All right. So I know that 12 and 2. So let me try positive 12, negative 2. 2x times negative 2 is a negative 4x. Oops. Okay. And 12 times x is just 12x. All right. So let's see. 12 minus 4 is not a positive 2. So that's not going to work. All right. Okay. Let me just switch them real quick. All right, so if this is 12 and this is 2, so 2 times x is 2x. 2 times negative 12 is negative 24. Oh, okay, so that's way far from a positive 2x. All right, so that's definitely not going to work. All right, so let's try 6 and 4, right? So I'll just put the 6 here, the 4 here. I forgot to erase this too. All right, so 4 times x is just a positive 4x. 2 times negative 6 is negative 12. Negative 12 plus 4 is 8, right? Negative 8. Okay, so let's switch them around. We'll get there. Okay, 6 and 4. All right. Okay, so 6 times x is 6x. 2 times negative 4 is negative 8. So negative 8x plus 6x would give me a negative 2x. Oh, I'm getting close. See, this is the exciting part, right? I'm almost there, right? So in that case, I just need to switch the signs, right? So 2 times a positive 4 would give me a positive 8x. And negative 6 times x would give me a negative 6x. And 8x minus 6x would match the middle term of a positive 2x, right? Because they've got to combine to get that middle term. All right, excellent, right? So instead of writing this factor, I'm going to change it. So I have 2x minus 6 and x plus 4. All right, so now I'm going to check for greatest common factor. I don't see one here. Oh, I do see one here. Does anyone see what it is? Okay, it is the 2. 2 goes into x, 2 goes into 2x and 2 goes into 6. Okay, so I can take that out, right? I can take out the 2. 2 times x gives me 2x, and 2 times a minus 3 gives me negative 6. Okay, so whenever I take it a greatest common factor, whenever I take like just one term, it like the 2 is not in a parentheses, it's just it goes in front, right? Whenever I take out a greatest common factor, I'm always going to put that greatest common factor at the very front. Okay, so I'm going to say b of x is equal to 2, right? So I have that 2 right here, and it's 2 times x minus 3. So they don't necessarily have to be touching because multiplication, commutative property, you can move things around, right? So this right here would be fully, completely factored. And I know it's a lot of steps, but other than just kind of being annoying that it's a lot of steps, it's nothing that you haven't done. They're just asking you to do what you've already done, but more times, right? Okay. All right, so we're almost done. And again, if you're someone that likes to watch the entire video, that's great. But if you're someone that's like, wait, I only had a question on 19 or like whatever it is, just skip through the slides and go to that one. All right, so cool. So now we have d of x equals x to the fourth minus 13x squared plus 36. And they give you not one, but two factors. Okay, and I actually feel like this will have a product of four factors. So I think that this might just be a typo because they do ask for an incomplete factored form. So let's see, maybe I'm wrong. I'll know once I actually do the problem. Okay, so here we go. Also, another thing to kind of notice is that it goes from x to the fourth to x squared. So the fact that I don't have a term in here that is x to the third means that that x to the third spot will cancel out. All right, just like it did in one of our previous problems. So sometimes what people want to do is they actually want to write out you want to write it out like this: x to the fourth. And then because there's no x to the third term, they just put in 0x to the third. It's kind of just like a placeholder. Okay, minus 13x squared. Oh, and I don't have an x term in the middle of 13x squared and 36. So let me do that again. I'm just going to put plus 0x. And again, 0 times anything is just 0. I'm just using it as a placeholder. And then plus 36. All right. So it's a lot, right? I'm going to start with one of my factors, right? Because I can't really factor and divide it out. I can't factor both of these and divide both of these simultaneously. So I have to do them separate. Okay. So I know one of my factors is x minus 2. And I know that when I start making my box, the top left-hand corner will have the first term of x to the fourth. X to the fourth. Okay. And now, oh, I'm not using that. Got it. All right, so here we go. So now x times what gives me x to the fourth? Okay, so it's x to the third. Remember, you add the exponents when you're multiplying. So x to the third times negative 2 is negative 2x to the third. Okay, cool. So now, again, remember, I don't have any x to the thirds. I want to cancel that negative 2 out. So negative 2x to the third would cancel out with the opposite, which is a positive 2x to the third. Okay, so 2 minus 2, 0, and that's exactly what I need for x to the thirds. So x times 2x squared gives me 2x to the third. Let me just, okay. So now the bottom, negative 2 times a positive 2x squared gives me a negative 4x squared. Now I do see that. I see I need a negative 13x squared. So I already have 4 of those negatives. So 5, 6, 7, 8, 9, 10, 11, 12, 13. I would need 9 more negative x squares. So I have negative 9x squared. Okay, so negative 4 minus 9 gives me this negative 13x squares. All right, so now x times negative 9x, right? X times x is x squared. So now negative 9x times negative 2 would give me a positive 18x. All right, hopefully we don't run out of room. Jeez. Okay, I'll have to write smaller. Okay, so now I don't have any x's. So again, I'm going to try and just cancel that out. So I'm going to put negative 18x. Okay, So 18 minus 18 is 0. That gets rid of my x's. All right. So now negative 18x. All right. So x times negative 18 would give me negative 18x. And negative 18 times negative 2, ding, 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 would give me this positive 36. Okay, so one of my factors is x minus 2. The other factor is what I've just found, x squared plus 2x, x to the third degree, right? X to the third plus 2x squared minus 9x minus 18. All right, so let me write that in here. So right now, at this point, I have d of x. And if you're watching, you're like, I don't get it, actually do the work with me, right? Actually type it out as I'm typing it out and work through my mistakes with me, right? If I make mistakes. Okay, so I started with this and I've realized, all right, when I factor it with x minus 2, I have x minus 2, and then the new factor that I got up here. All right, so now x to the third plus 2x squared minus 18. Okay, great. Now, they actually gave me not one factor, they gave me two factors. So I know x plus 2 is also going to be a factor for me. All right, I can use that to factor this part even more completely. All right, so again, I'm gonna erase what I've done here. All right, which is another reason why it is fantastic for you to get your notebooks out and to actually be following along. Okay, wait, why isn't this? Oh, because I need to. Okay, all right, so. All right, and I'm actually gonna get rid of this. All right, so we've already factored that. The new thing that we're factoring, we're like zooming in on, right? I have x minus 2, right? That's a linear. If I just were to graph x minus 2, that's linear. So that's factored enough, right? Here, I've got a cubic, right? So this is my new kind of standard form that I'm zooming into, and I wanna break that up more with little factors. So I'm just going to write that up here just to remind myself. So here I want x to the third, 2x squared minus 9x minus 18. Okay, cool. Alrighty, so I know that my other factor, wait, I don't want to do that. Yes, I do. Okay, I know that my other factor is x plus 2. So I've already got this factor. This factor is right here. All right, so I'm going to use x plus 2 plus 2. All right, and I'm going to use the box method to divide that out of this cubic function. All right, so I know the first term of x cubed will be in this top right, or sorry, top left, top left-hand corner. All right, so now let's do the rest of it. X times what is x to the third? X squared. All right, now that I know that, x squared times 2 is 2x squared. Okay, now with the x squares, I want 2x squared. Oh, so I don't want anything else. I've already got 2x squares. So up here, I just am saying, hey, I don't want any more x squares. I got them, it matches, I'm great. Okay, so now x times 0 x's would give me 0x squareds. All right, now 0x, again, it's still just 0, it's just 0, right? But we're just pretending that the x is real, you know, to kind of keep a space open for it. All right, so 0x times 2 would give me still 0, And I'm just going to put X because, again, it's just kind of a placeholder. All right, now I want negative 9x's and I have 0. So I'll need another negative 9x's so that when I combine these, negative 9x plus 0x will give me negative 9x. All right, I know that's a little confusing, but the more you practice, the easier it will get. So now here, x times negative 9, okay, will give me negative 9x. And it looks like I've come to the end of this because negative 9 times a positive 2 will give me a negative 18. And look at that. I should end at negative 18. Okay? So now, do I need to write plus 0x? No, right? I mean, you can. I'll show you, right? So instead of writing out this cubic, I've now factored it with the factor that they gave me, x plus 2, right, which is on the side in red, right? I put that right here. And it factored with x squared, and I'll just put the 0x, sure, why not, minus 9. Okay. So 0 times x is still 0, and 0 plus or minus anything, just it doesn't change anything. So this factor would be x squared minus 9. All right, and I'm not gonna do the whole thing because it's really similar to where we ended up with x squared minus 16. So if you need kind of a review, but this is also a difference of 2 squares where you need to cancel out the x terms. So this will turn into, actually, let me just do, oh, I'm trying to erase it with the wrong eraser again. Okay. All right. Okay, so this one, all right, the x squared minus 9, it's a quadratic if I'm zooming into it, so I know it's going to have these 4 spaces, minus 9. Your factors would be x minus 3, oops, and x plus 3. Okay, so again, just like when we had negative 16 here, we had negative 4 and positive 4. This negative 3x will cancel out. Maybe I'm trying to go too fast. This negative 3x and positive 3x, those will cancel out to 0x. All right, so when I go back here, instead of writing x squared minus 9, I can write x minus 3 times x plus 3. So yeah, so this was actually 4 factors, not 3. This was just a typo. Yeah, this should have said the product of 4 factors. So I have 1, 2, 3, 4. You should all know that x to the 4th has an end function similar to x squared. So I would start up, end up. There might be some ups and downs in between, you know, and that it would cross. Oh, and there would have to be because it would cross the x-axis in 4 places: at positive 2, at negative 2, at positive 3, and at negative 3. So yeah, there will probably be a few bumps along the way. Okay, and we just have one more. And that is slide 20. Now, we've been here for over an hour. I feel like if you understood the last one, you are more than free to just try it on your own. I will go over it because someone requested it. So again, if you want to stay, oops. Oh, I don't know what happened there. Again, if you want to stay, great. But if you want to go, that's fine too. Okay. So again, I'm just going to choose one of the factors to start with. And I'm going to say x minus 3. And then what I am factoring starts with a 4x to the third. So that gets to go in the top left-hand corner. All right, so let's change colors. Oh, let's change colors down here. Okay, so x times 4x squared would give me 4x to the third. All right, now I do 4x squared times negative 3. That would give me negative 12x squared. All right, so I look over here. I need negative 11x squared. So I have negative 12x squared. So I just need to add 1x squared to that to bring it to negative 11x squared. Okay, so negative 12x squared plus x squared would give me this negative 11x squared. All right, so now x times x would give me x squared. All right, and x times negative 3 would give me negative 3x. Okay, now negative 3x, I want negative 6x. All right, so negative 3x minus 3x would give me that negative 6x. All right, so negative 3x, so that would be x times negative 3. All right, and negative 3 times negative 3 would give me this positive 9 that I see. All right, so instead of writing it completely out in standard form, I'm going to go here and I'm going to say, hey, it's equal to the factor x minus 3 times the factor of 4x squared. Oh, wait, wrong direction. Okay. 4x squared plus x minus 3. Now, again, I got to keep factoring it, right? So let me just clear this. Oh, I like that better. Okay, I'm going to use that in the future. All right, so now I am not factoring 4x to the third minus 11x squared minus 6x plus 9. I'm now factoring just what's in this new parentheses. Because again, if I look at this one, x minus 3, that would be linear. If I graphed it, x minus 3, it would be a line. Anything that is not linear, I know I can factor further. Okay, so here I've got 4x squared minus x, or sorry, plus x minus 3. Okay, come on. Great. All right, so 4x. I just like writing it down so I remember what exactly I'm factoring. Minus 3. All right, so now I did this factor, right? I got that here. Now I'm going to use this factor. So I'm going to say x minus 1. Okay, and again, my top left-hand corner is going to be filled with the first term, 4x squared. Okay, and now I get it cranking from there, right? So x times 4x would give me 4x squared, right? 4x times negative 1 gives me negative 4x. All right, so how many x's do I want? I want just one, and I want it to be positive. So here I'm going to do plus 5x, because negative 4x plus 5x would give me a positive 1x, right, or positive x. All right, so now x times 5 would give me 5x, okay? And here, 5 times -1 would give me -5. So let me just make sure real quick that this was good. 4x to the third, x squared. Okay. So let me pause this for a second. Okay, I am back. I actually took a few minutes and I paused the video to be like, what is going on? Because this does not work. And what I found out, and I apologize for, because usually these videos are pretty good, or usually these Desmos activities are pretty good, but they actually meant to put x plus 1 and not x minus 1. So they just made an error. They made a mistake. So if you thought that you got the lesson and this was driving you crazy, then you're absolutely correct, right? So let's change this to a plus 1, all right? And take it from there, okay? So I have 1 times 4x, which is a positive 4x. And again, I want to get to a positive just 1x. So let me, actually, I don't know how to erase on this thing. Yes, I do. That's a lie. Here it is. Okay. Okay. All right, so I have a positive 4. I would need to take away 3 x's to get to that positive x. All right, so here I have a positive 3x, and x times 3 gives me 3x. And then 3 times, wait, did I do that right? Why did I have -3? Yes, because I'm taking away 3. So 4x minus 3x gives me this positive x, okay? So x times -3 would give me -3x, all right? Now, -3 times 1 gives me, sigh of relief, this -3. Okay, so again, I'm really sorry about that. That was just a mistake here. This was x minus 1. It should have been x plus 1. All right, so let's rock with it, right? Mistakes happen. But the good thing is when you know how to do your algebra and you have strong algebra skills, you should be able to say, hey, this does not make sense, right? With a little bit of confidence. Okay, so I'm going to take this quadratic away and I'm going to change it to x plus 1 times 4x minus 3. Okay, so I do have it as a product of 3 factors. They are all, like if I look just at them individually, they're all linear functions, right? So x minus 3 would be a line, x plus 1 would be a line, 4x minus 3 would be a line. I'm also looking to see, are any of them greatest common factor? And I don't see for any of them, right? So yeah, you should have used both of the factors that were given to you, and hopefully there will not be mistakes in the future. Both of the factors that were given to you, and then use that to factor completely and find that third factor. Okay, so yeah, that was a long one. All right, well, I hope that you got something out of this. Feel free to email me. I am trying to set up some office hours, so thank you for filling out that survey. And that is all for today.